Hello everyone, welcome back. We are done with creation and display operations in circular linked list. Now in this session, we are going to discuss about the insertion operation in circular linked list. After taking this session, you will be able to explain the insertion operations in circular linked list. You will be able to create and insert a new element at any position in circular linked list. Let us discuss the insertion operation in circular linked list. This can be performed in four ways, like a singly and doubly linked list. We can insert a new node at the beginning of the list as the first node. We can insert the new node at the end of the list as the last node. We can insert a new node after a given element, and also we can insert a new node before the given element. Let's look into each case in detail, each operation. Insert a new node at the beginning of a circular linked list. Let us take this example, a circular cube with three nodes, with the first node always representing with the name head and the last node referring with the name last. Now you try to insert a new node 40 at the beginning of the list. Now further what you should do, you need to allocate memory for a new node and then insert the data value as 40 and make the next part as null. And this node we are referring with the name n. Now, as you are making this node as the first node, you need to connect this new node with the head node. Then establish a link between the n and head just by simply storing the address of n, address of head in the next part of n, like n arrow next equal to head. Now after attaching n to the list, now n is becoming the first node. Now here in the circularly linked list, the last node should store the address of the first node. Here the first node is 4000, but the last node is holding the address of 1000 because earlier the 1000 is the head. So in that situation, you need to move head to the newly created node. Now head is n now. Now give the links between the last and head, like last arrow next equal to head. Then coming to the implementation, see the function, allocate memory for the node structure, insert the data value, make the next part as a null. Now give links between n and head, move head to new node, and then give the link between the last and head. Now the next insertion is insert a new node at the end of the list. Again, take the same example, a circular linked list with three nodes. Now insert a new node with the data value 40 at the end of the list. So just allocate a memory for the node structure, refer that memory with the name n, insert the data value as 40, make the next part as null. Now this you should attach at the end of the list. In that situation, you need to give link between the last and n. That means the last next point, next field should store the address of n. Now last is connected with n. Now here in this situation, the n is becoming the last node, but still last is pointing to 3000. Hence move last to en. Now last is pointing to 4000, but whose next field is still storing the value null, but it should store the address of the first node, which is 1000. Then give a link between the last and head. Now see the implementation. Allocate memory for the node structure. This is insert last. Allocate memory for the node structure and then assign a data value. Make the next part as null. Give links between the last and n. Move last to the new node and then connect last with head. The insertion operations in terms of after and before the given elements are very similar to singly linked list. Let's take the scenario where a singly linked list of 4 elements. Just you take it as a circular linked list of 4 elements. Now in this list, I am trying to insert a new node 50 after 20. Just simply allocate memory for the node structure and make the next part as null. Here, give the links. So first you need to search for the element 20. Make a search for the element 20. and then that node will refer with the name temp. The next node will refer with the name temp arrow next. Now give links between temp n and temp arrow next. The simply n arrow next storing the address of temp arrow next, that is 3000, and the left link the temp arrow next storing the address of n, that is 6000. Now this implementation is very similar to single linked list. Just start searching for the key value from the first node. So whenever you are able to locate that element, come out of the loop, or otherwise make a move of temporary pointer. Give the right side pointer, and this is for the left side pointer. Now see the insertion before the given element. Where here, this is a circularly linked list of 4 nodes. We are trying to insert a data value 50 after 30. After 30, you want to, not 30, before 30, you want to insert the new data, new element, a new node with the data value 50. Now allocate memory for the node structure as usual and insert the data value as 50 and make the next part as null initially. Now make a search to locate the element 30. Now this node becomes temp node. So whenever we are moving temp to the next nodes, you need to store the information of temp into another pointer, that is previous. Now this node is previous, whereas this node is temp, and this is the newly created node. Now give links between these three, as n next field stores the address of temp. Like n arrow next equal to temp. Similarly, for the right pointer, the previous arrow next equal to n. The previous arrow next is storing the address of n. The implementation for before, which is very similar to single linked list. They allocate memory, initializations, read the key value. Starting from the first node, search for the key value. If you are not able to search, then store the temp in previous pointer and move temp to next node. The right side link, which is the connection between the new node and the next node, that is a temporary node, and this is the link between the previous node and the new. This is about the insertion operation in circular linked list. Let's see the implementation. To the previous code, we'll add 2 functions, void insert begin and then void insert end. We are not implementing before and after. We are done with it in single linked list. Insert begin, the function call, and then break. Insert after, not after, insert end, the function call and break. Now include in menu options, insert begin as 4th choice, and insert after, not after, it is insert end as 5th choice. Let's take the choice variable till 5. Now implement insertions. Insert begin. Here the same as usual. Allocate memory, make the next part null, and so on. And now give link between the n and head. N arrow next equal to head, and then make n as head, and then last arrow next equal to head. Now we'll define insert n, The function name is insert n. Take a new node, and then here links between the last and n, last arrow next equal to n, move last to new node. After moving, give link between last and head, last arrow next equal to head. Let's run the code. Now create circular linked list with the 3 elements 10, 20 and 30. Now display list elements. So it is printing 10, 20, 30. Now take the choice as 4 to insert a new element at the beginning. I'm trying to insert 40 at the beginning. See the effect of it. Yes, 40 got inserted at the beginning of the list. Now check with fifth option. Insert an element at the end of the list. Let's see the output. Yes, 50 got inserted at the end of the list. So this is an insertion operation in circular linked list.